Do you agree?
Sure, I'm Taehyun James Rhee, simply call me TJ. I'm a director of Computation and Media Learning Center. We call it CIMIC from Victoria University of Wellington. So today's session topic is research direction. So I think research means innovation, and the direction that I talk today is immersive and interactive, intelligent, and focused. So I have a short introduction for CIMIC. So this is a Google map where the CIMIC is. So this is a CIMIC near the ocean, and it looks like that. That is Victoria University satellite campus, but in the CBD of Wellington. So we have lots of good cafe, breweries. So this is good for collaboration. And I zoom out, and then I see our location is actually center of this country. So our vision is to be a hub for digital media frontier, and we are working for innovating the digital media ecosystem and platform, and trying to lead the innovation for immersive and interactive and intelligent technology. And also we want to deliver the value to human life. So we have three teams. So CMS, three groups. So CMS group, Computational Video Solution Group. Their background is computer graphics, vision, AI, machine learning, audio and video processing. They are actually developing the solution for future platform. And we have a UXR group. So user experience and XR group. They are the expert in VR, AR, MR, and XR, and user interface and user experience and ATCI. They actually design the user experience for future media service. We have another group called AMP, Advanced Media Prototyping Group. They are working for making actual video application and content to pitch out to the industry and end user. So these three groups work tightly together to give the value for future digital media. So we have 4 cycles. So we are not just doing research. We wanted to deliver the research outcome to the real world. We have a prototyping stage to take the research outcome from the paper to actually making a working platform to provide the industry and end user. And also wanted to work for the industrialization for tech transfer, and also startup, a spin-off, and the licensing. And also this kind of thing can incubate another project for our research and collaboration. So we wanted to make this cycle working in our center. So without having the network and collaboration, we cannot deliver the value. This is our current collaboration network. As Mark said in the opening, we have a part of the ORIF network working together with the University of New Zealand and Australia. And also we have lots of connection in Asia and US and Europe, the UK. And also, before joining Victoria for 2012, I worked for Samsung for 17 years to lead their computer graphics research and disability research. So I will talk about the media, 3I media technology from now. So recently I checked that everybody was so busy, so I tried to check how many projects we are currently working. I think it's more than 20. So we categorized it in 3 programs. I think it's quite fit to immersive and interactive intelligent concept. The first program is using XR technology for teleportation and remote collaboration. The second program is to deliver a new solution for studio artists using the computer graphics and simulation applying mathematics. And third one is to use AI to solve a computationally heavy problem that has been a problem for the XR research and computer graphics research, but now they can be solved by big data and AI and machine learning. So first program, XR teleportation and remote collaboration. So we have lots of partners work together for this environment. I think this is kind of a thing that is impacted by COVID and have an opportunity there. So this is an example of 360 video showing this is a recording from the headset. As you can see, we have a good telepresence and to capture the location. This is great. But there's some missing. So we cannot have interaction with the scene. This is what we do. So this is augmented reality into 360 video, and high fidelity rendering and lighting have a coherent lighting and composition with the background. So this is a real-time video effect that has been used for the film, but applied in real time in the immersive setting. So people may have some illusion that they are acting, interacting with the scene object in the immersive video environment. So this is kind of a convergence of immersive and interactive media into mixed reality. We work with Vera, and they have a great pipeline to create a high fidelity mixed reality output. As we can see, our troll and actor are all in the video. So we immerse in the story and a high presence in the story. But the media is great for the presence, but this is based on the recorded media. So all the thing can be done offline and manual blending. This is great. But if we have an interactive media like a game, AR, that needs to be done in real time and automatically. So, for example, Pokemon Go, we have real-time rendering and we have automatic blending, but the fidelity of the virtual character is low, so we got interactivity, but presence is low. The thing that we are trying to do is to combine immersive and interactive technology all together to solve this problem in real time automatically to achieve the interactivity also of high presence. So this is an example. So this is not concept video, this is a working video. So we can have a virtual playground with the fish in the Wellington civic scale, and everything in the lighting and shadowing is done automatically with our arms. So this can be used for the virtual production. They can go outside and check the lighting and the asset interactively remote. Also, it can be used for simulation of interior design, so we can have a lighting simulation and we can lay out, and we can buy the furniture from online store. The Wayfair is all of the online furniture company in US. So this can be done remotely and virtually in the visibility situation. And also, this is done before COVID-19, and we thought, so there's no audience here, so it's a little bit awkward, but this is common now. So in order to have like a live broadcasting in the sport field, we need to connect, but we can be in the home safely and then see the sport event more immersively in the live streaming. So we also work with a local company, Wrestler and Wellington Airport and Singapore Airline for the virtual tour in mixed reality. For example, the people are sitting on this tri-shell and then watching the mixed reality scene, and then they can virtually teleport to the tourist spot for the Singapore Airline. So like in the Phuket, they put the Wellington, and also in the London, they can jump with the marching band. So that's one of the problems that I just mentioned, and the other problem is the Future Studio solution. So the thing that I just mentioned was made as a toolkit that can be available for the studio artists to create their own content. As you can see, when you change the background, the lighting and shadowing is automatically done. The artist can drag and drop to create their scene easily. And also we made an underwater version of that. We provide some video effect on the water, and people can have a nice high fidelity visibility. This can be used for the simulation on the water, so probably possible to be used for the educational purpose. And also we work for the heavy workload for the mesh decimation automatically. So we reduce the 14 million polygon to the 14 million all vertices, 250,000 vertices. Left one can be asset for the film, but right one can be the asset for the interactive media. Okay, the last slide, a little bit rushed, it's too many things. The third one is to use AI for solving this kind of problem. So this is an example of the path trace rendering that is used for the film to create a high fidelity output. So in order to render this one scene, it took 10 hours. So we sampled the thousands of array from one single pixel. It took a lot of time. When we create the animated scene, it's huge amount of time. The thing that we are doing is to use only 20% of pixel and then recover 80% of pixel using machine learning. That means theoretically we can save 80% of rendering. So what is the AI reconstructed image? Left is image. So the researcher wanted to compare with the other, and we want to like we are stable and more fast. So this is a thing that we can show compare with the others, and based on the reference with the full rendering, we can create a very plausible result with this kind of rosy. So the computer graphic people are working for rendering. So we put a light, camera, and reflectance and geometry and push the rendering button, and then we can create nice image. But the thing that we need to do in AR and XR, we need to provide some virtual information to be blended into this image. So in order to do that, when we given input photo, we need to estimate light, geometry, and camera location and reflectance model. That's the inverse rendering problem, quite a difficult problem. And many researchers are working for camera localization and geometry reconstruction, and we focus for solving the other important part, lighting. So when we take a photo using mobile app, we can have this kind of partial view image. So in the normal setup, we have a 360 view, and then we can have 360 panorama for environmental lighting information. So we can render the nice image like that. But often we cannot have a 360 panoramic image in mobile app and AR. So what we can do is to estimating the surrounding light using the partial view image. So this is very difficult. The human, I don't know if human can do it, so just take a picture and estimate the light. But machine can do this kind of heavy work on behalf of us. So we are using the standard convolution neural network and train the neural network from easy to hard, and then we reconstruct the reflectance map from the low to high process. This is a result. The left one is input photo. The middle row is our estimation. So using that partial view, we estimate the surrounding light, which is very similar to quantum. It's a little bit blurred, but it's okay for lighting. The other scene is okay. And also we work for the indoor scene. This is very, very challenging. We solve the solution as well. And also we applied it for our AR app, so this is available. So if you ask, you can download it and we can share it with you. So the last thing that I wanted to share, so I'm not sure I have enough time for doing it, is to combine all the things in the live streaming media for providing the XR collaboration. So I will skip that part. The thing that we do is we live streaming 360 video and do the thing that I did before in live. That means if we have a VR headset, we can see happening in the remote space through the VR headset without driver, and then we can have full awareness of the work site. And the people in the work site can have an AR headset, and then he can see the overlay 3D avatar of the 360 camera. This is a combination of VR and AR into mixed reality. This is a working prototype. So this is the AR view, and this is the AR person view, and the red yellow line is the remote person who has been teleported. They can lively talk together and work together in remote collaborative space. So I'd like to share more and more, so I will be rushed. So this is the last concept video. This is the only concept video. The other video is actual capturing video. So this is to show what is happening in the future and why combine all this kind of technology together. We call it the AVT, Augmented Virtual Transportation. Not just AR, not just VR, all together in this one platform. Yeah, so this is a part of our research. We wanted to provide a platform that can be shared to help the local industry and the engagement for the global competition. So I hope to, this is a little bit cheesy, that our center is for innovation. Innovation is changing something. So I think we can make the change if we work together. Thank you.